Welcome to another video lecture of numericals and clamper. So today we are going to discuss about another numerical where you can see the input voltage is given as Vi, which is a square wave of 10 volt. So you can see maximum voltage is 10 volt and minimum voltage is minus 10 volt. Here we are providing a reference voltage of 4 volt which is connected to the diode, the reverse way, and the RL I am taking 10 ohm and the capacitor value is 1 microfarad. So our main objective is here to find out what is the output voltage V0. As you know from the previous videos, we have already discussed this type of numerical. So here first we need to, you can see here the nodes which is connected above, these two nodes are same, and below that these two nodes are same. So the voltage across the load resistance as well as the voltage across this diode as plus this 4 volt battery, both are same, that is V0. Now if we can find out what is output voltage V0, then we need to apply your KVL. So applying KVL here, I can write down Vi minus Vc minus V0 equal to 0. Then after that we can find out V0 equal to Vi minus Vc. As like every problem, we have to calculate what is Vc, that is the voltage drop across capacitor, which is unknown to us. So you can see I already told before, when the diode is forward biased, at that time only the capacitor will charge. Now you can see to the diode the 4 volts negative part is connected, and this diode can be forward biased if I can connect, if the negative half of the input voltage, that is will be connected. If you connect the negative voltage, then only the negative half of the input, then only the diode will be forward biased. So if the negative half of the half will be connected, or negative half of, then the battery terminals or the Vi, the input and output terminals will be reversed. So the down part will be plus, the up part will be minus. So if we can redraw this diagram, then we can draw like this. So negative terminal will go up, the positive terminal will go down, then the volt capacitor here, which is the voltage drop equal to Vc, and there is a 4 volt reference voltage which is connected like this. So you can put here 10 volt and here 4 volt reference, and we need to find out what is the uh, voltage drop, or you can see that what is the maximum voltage the capacitor can hold. So now after applying KVL here, you can see here applying KVL, so you can write down plus to minus minus 10, then plus to minus again minus Vc, then minus to plus 4 volt equal to 0. So by solving this, I can find out your Vc equal to minus 6 volt. So now this whatever Vc is unknown, now it is known to us. So after putting this Vc in the output voltage equation, I can get V0 equal to Vi minus Vc, or I can say that Vi, by putting this I'll get that Vi plus 6 volt. Okay, so our output voltage is now V0 equal to Vi plus 6. So here in this equation, your Vi is variable. So input voltage is variable. By putting different input voltages, I'll get different output voltage. So you can see here the waveform starts from 0. So when Vi equal to 0, at that time you will get V0 equal to 0 plus 6, that is 6 volt. Similarly, when this input voltage reaches maximum value, that means when Vi equal to 10 volt, I will get V0 equal to 10 plus 6, that is I will get 16 volt. I will get V0 equal to 16 volt. Similarly, if I will put Vi when Vi equal to minus 10 volt, so I will get here V0 equal to minus 10 plus 6, that is minus 4 volt. Okay, so this is basically different output voltages for different value of input voltage. Now we need to draw the output and input waveforms for this. Now first I need to draw the input voltage, which is a square wave having amplitude plus 10 to minus 10. So let this is 10 to minus 10. So now you can see here. So now I need to draw the output waveform. So first I need to put the marks. So you can see I just put the marks like 6, 16, then minus 4. So let me put first 0. So this diagram will go up. That's why we'll just draw the axis, x-axis again. So 0, we'll put 16. Then it is 6, 16. Then the below I have to draw minus 4 volt. Okay. So once this over, then first we'll check when Vi equal to 0 volt. Then you can see the output voltage will be 6 volt. That means this waveform will start from 6 volt. So from the 6 volt, basically you can think that this is a reference line for the x-axis. Okay. Then we'll start this signal from the 6 volt. So it will go up. So let me so it like the input voltage going from 0 to 10. So it will start from 6 and it will go to 16 volt. Okay, let me redraw this diagram. I think this diagram is not exactly symmetrical. Wait for this. Okay, so I need to erase it. Okay, so actually 6 to 16 it should be looking like 10. That's why. Okay, I need to. Okay. So again, when this input waveform you can see starts from 0 going towards 10. So the output waveform will start from 6, will going towards 16. Then when the input again it will come back to 0. Okay, so it will again come back to 0. Then when Vi equal to minus 10 volt, your output voltage will be minus 4 volt. Okay, so it will start from 0 to minus 10. So in this case, it will start from 6 to minus 4. It will go 6 to minus 4. Then again it will come back to 6. Okay, then it will come back to 6. So you can see here, the waveform look like this. So it is the same square wave. So the as input is having starting from 0 going towards 10, then it will come back to 0, then it will go to minus 10. So in this case it will start from 6 volt, will go towards 16, then again come back to 6, then it will go to minus 4, then after that it will go to 6 again. Okay, so let me say there is some problem here. Okay, let me rectify this. Okay, anyhow, you can see, I think you understood. If you can check here and if you can find out peak to peak voltage in both the cases, you can check in the input side the peak to peak voltage is equal to 20 volt. It is 10 minus 10. This is 20 volt. Similarly, here also we can find out the input voltage also 16 minus 4 minus 20 volt. So now in this green color, I just want to picturize how the output waveform look like. See, this is again a square wave where the reference is starting from 6. So from the 6 it will go to 16 and come back to 6. Then in the negative side it will go to minus 4. So you can see the input voltage which is starting from 0. Now the output voltage is starting from 6. Basically this particular waveform I just went up. Okay, it just went up. That's why it acts as a positive clamper. If you have any doubt, you can ask me in the comment section. If you think that this video is helpful, then you can share with your friends. Thank you for listening.